August 17, 1943, 18,000 feet over the Solomon Islands. Lieutenant Richard Bond watched his wingman's P-38 Lightning spiral down into the Pacific below. 3 Japanese Zeros had dropped on them from above, and now Bond was alone. The lead Zero tightened in on his tail. He had perhaps 4 seconds before 20mm cannon shells ripped through his aircraft. What happened next was nowhere in any training manual. Bond rolled his P-38 fully inverted and hauled the stick forward. Instead of climbing away from danger, his fighter plunged toward the ocean, but because he was upside down, he pulled in a direction the Zero pilot never expected. Blood surged into his head, his vision reddening at the edges. The Pacific filled his canopy where sky should have been. The Zero pilot, convinced Bong would climb, overshot the attack. In those 3 seconds of confusion, Bong rolled upright beneath the Zero and pulled up hard. His .50 caliber machine guns raked the Zero's belly from a position no Japanese pilot had ever faced an American fighter striking from below. The Zero broke apart in midair. By August 1943, American pilots in the Pacific confronted a harsh reality. The Zero could outturn any American fighter, and Japanese pilots exploited that edge relentlessly. Standard doctrine instructed American fighters to rely on superior speed and firepower, dive, fire, and climb away, never turn with a Zero. The statistics told a grim story. During the first year of Pacific air combat, the Zero achieved a kill ratio approaching 3-to-1 against American aircraft. The A-6M Zero could turn inside a circle roughly 400 feet tighter than a P-38 at combat speeds. When an American pilot tried to dogfight, the Zero simply tightened its turn and maneuvered into firing position. Lieutenant Colonel Thomas Lynch recorded the problem in his August 1943 after-action report. American pilots retained a speed advantage but could not survive sustained engagements. The moment they slowed or turned, the Zero dominated, trading 1 Japanese loss for every 3 American aircraft destroyed in turning fights. The P-38 Lightning did offer strengths. Its twin Allison engines produced a combined 2,600 horsepower, giving it a top speed of 414 miles per hour. Its armament, .50 caliber machine guns and a 20mm cannon concentrated in the nose, allowed devastating firepower in a single pass. A P-38 pilot who preserved speed could destroy Zeros quickly. But combat rarely unfolded under ideal conditions. Japanese pilots had been fighting since the late 1930s over China and possessed expert understanding of energy management. They knew precisely how to force American pilots into situations where the Zero's turning ability became decisive. A common tactic involved 1 Zero acting as bait, flying straight and level to appear vulnerable. When an American pilot committed to the attack, 2 more Zeros would drop in from above or slide in from the flanks. Suddenly defensive, the American fighter entered a turning fight, and once that happened, the Zero's advantages became overwhelming. What Bong discovered that day over the Solomon Islands was something aviation medicine considered impossible. The maneuver involved rolling inverted and pulling through into a diving turn. In normal flight, pilots experience positive G-forces, with blood pushed toward the feet, narrowing vision. At around 5 to 6 gs, many pilots gray out or black out entirely. But when a pilot rolls upside down and pulls forward on the stick, negative G-forces occur. Blood rushes to the head, producing an effect known as red out, in which the visual field literally turns red as blood vessels and the eyes engorge. Aviation medicine in 1942 suggested humans could scarcely tolerate negative G-forces. Studies indicated that even -2 gs caused severe discomfort, disorientation, and potential retinal damage, and official guidance recommended avoiding negative G flight altogether. Those studies, however, were conducted in controlled environments with test pilots who were not being shot at. Combat changed the equation. A pilot who endured 2 seconds of red out but escaped a Zero's gun solution lived. A pilot who maintained perfect positive G flight while remaining in the Zero's sights died. The choice was not comfort versus discomfort. It was temporary blindness versus permanent death. The physics behind the inverted dive involved energy management and enemy expectation. When a Zero pilot gained a tail position, he anticipated the target would either try to outturn him, which was futile, or attempt to climb away, bleeding energy and becoming an easier target. The inverted dive did neither. It converted altitude into speed along a vector the Zero pilot did not anticipate. More importantly, if the Japanese pilot tried to follow, his aircraft encountered structural limits. The Zero was stressed for positive G loads up to about 7 gs, but its light construction made negative G flight especially hazardous. Pulling negative gs risked structural failure or engine problems, as the aircraft was not designed for sustained inverted operation. The P-38's twin Allison engines offered another advantage under negative G. Unlike single-engine fighters with carbureted engines that could suffer fuel starvation when inverted, the P-38 used fuel systems that function more reliably during negative G maneuvers. This was not intentional. Lockheed engineers never designed the aircraft for inverted combat, but it became operationally significant. A P-38 pilot could maintain power through an inverted dive, while pursuing aircraft might lose power momentarily, increasing separation. Human tolerance for negative G-forces proved higher than medical literature suggested, provided exposure was brief. Pilots reported that readout lasted only seconds during a properly executed split-S maneuver, with vision returning as the aircraft transitioned back to positive G during the pullout. The discomfort was severe headaches, facial pressure, aching eyes, bloodshot vision, but survivable. Several pilots remarked in debriefings that they preferred a splitting headache back at base to a formal burial at sea. The informal risk calculation was simple: negative G maneuvers hurt, but Japanese cannons hurt far more. Major Thomas Lynch of the 39th Fighter Squadron, flying P-38 Lightnings from Port Moresby, New Guinea, was the first pilot documented to use the inverted dive deliberately rather than instinctively. On April 11, 1943, Lynch led a four-plane patrol over the Huon Gulf when his formation encountered 8 Zeros at 20,000 feet. Instead of engaging in a conventional horizontal fight, Lynch immediately rolled inverted as the lead Zero closed on him. He pulled into a steep dive, accelerated beyond 400 miles per hour, and leveled off at 8,000 feet. The Zero pilot, attempting to follow, pulled out at 12,000 feet, either unable or unwilling to match Lynch's dive angle and speed. Lynch did more than survive, he reversed the engagement. After leveling out, he possessed both altitude separation and superior speed. He used that energy advantage to climb back up, this time approaching the now disorganized Japanese formation from below. The Zeros had lost cohesion while chasing what they believed were fleeing American fighters. Lynch shot down 2 Zeros in the ensuing fight, and his wingmen, following him through the inverted dive, survived without losses. The after-action report noted the tactic but did not emphasize it, as official doctrine still discouraged negative G maneuvers. What made Lynch's action significant was its intentional use. Other pilots had rolled inverted under duress, survived, and chalked it up to luck. Lynch recognized it as a repeatable technique. Within a week, he was teaching the maneuver to other pilots in his squadron during informal briefings. The instruction was simple: if a Zero gets on your tail in a position where you can't shake him conventionally, roll inverted, pull through, dive hard, and use the speed to separate. Don't try to outturn him horizontally. Use the vertical dimension. The Zero owns the horizontal circle, but American fighters owned the vertical dive. By June 1943, the tactic had spread to other P-38 units operating out of Guadalcanal and the Russell Islands. Pilots shared the technique during ready room discussions and inter-squadron debriefings. It remained largely unofficial, not prohibited, but not endorsed in formal tactical directives either. Squadron leaders recognized its effectiveness, but hesitated to put it in writing. The concern was partly liability. If a pilot was killed attempting the maneuver, questions would arise about who authorized teaching a tactic that contradicted established training. So, it spread through word of mouth. Experienced pilots showing newer arrivals how to execute it without documenting the instruction. Flight Surgeon Captain James Moorhead, stationed at Henderson Field on Guadalcanal, began documenting the physical effects of negative G maneuvers in July 1943. His medical reports, which remained classified until 1947, provided the first systematic analysis of what pilots were actually experiencing. Moorhead examined 17 pilots who had executed inverted dives during combat between May and August 1943. Every pilot reported the same visual phenomenon. Vision went red within 1 to 2 seconds of pulling negative Gs. The redness started at the periphery and moved inward. For most pilots, central vision remained functional for 3 to 5 seconds during the maneuver, enough time to maintain aircraft control and execute the escape. After landing, pilots exhibited predictable physical symptoms. Petechiae, tiny red dots caused by broken capillaries, appeared on their faces, particularly around the eyes and across the forehead. Severe headaches lasting several hours. Bloodshot eyes from increased ocular pressure. One pilot reported temporary double vision that resolved after approximately 6 hours. Moorhead's most significant finding was that repeated exposure didn't cause cumulative damage. Pilots who executed The maneuver multiple times showed the same symptoms each time, but no worsening effects. The human cardiovascular system adapted to brief negative G exposure better than medical theory predicted. The key word was brief. Sustained negative G flight of more than 10 seconds did cause more serious problems, including potential retinal detachment, but combat maneuvers rarely required more than 3 to 5 seconds of inverted flight. The medical data provided unofficial validation for what pilots already knew from experience. The maneuver hurt, but it wouldn't kill them. Japanese cannon firewood. By September 1943, the inverted dive had become standard procedure in several P-38 squadrons, though still not officially documented in training materials. The tactical situation in the Pacific was changing. American production had begun overwhelming Japanese numbers. More P-38's arrived monthly. Pilot training improved. The Zeros, which had seemed invincible in 1942, now faced opponents who understood their strengths and limitations. Japanese pilots noticed the change. Saburo Sakai, one of Japan's highest-scoring aces, wrote in his post-war memoir about encountering American pilots who used vertical maneuvers that seemed suicidal but proved effective. The Lightning pilots stopped trying to turn with us. Instead, they would roll inverted and dive away at speeds we could not match. When we pursued, they would reverse and attack from below, a position we never expected. The psychological impact was significant. Zero pilots had dominated the Pacific Air War through superior turning ability. American pilots who refused to engage in turning fights negated that advantage. The inverted dive was particularly frustrating because it converted what should have been a kill position into a neutral situation, or worse, reversed the advantage entirely. Lieutenant Robert Westbrook of the 475th Fighter Group recorded an engagement on November 8, 1943 that demonstrated the tactics' effectiveness. His four-plane P-38 patrol encountered 9 Zeros over Rabble at 14,000 feet. The Zeros had the altitude advantage and dove on the American formation. Instead of breaking left or right into a horizontal turn, all four P-38 pilots rolled inverted simultaneously and pulled through into steep dives. The Zero formation, expecting a turning fight, overshot. The P-38's accelerated to over 420 miles per hour in the dive, opening separation from the Zeros. At 6,000 feet, the American pilots pulled out, reformed, and climbed back into the fight with both speed and positional advantage. The Zeros, now at lower altitude and having burned energy in their initial attack, couldn't regain advantage. Westbrook's flight shot down 3 Zeros without losses. His after-action report specifically credited the inverted dive with preventing what would have been a disadvantageous engagement. The tactic's effectiveness came from exploiting multiple factors simultaneously: speed separation, altitude conversion, opponent disorientation, engine reliability under negative G loads, and perhaps most importantly, pilot willingness to endure temporary physical discomfort for tactical advantage. That last factor proved decisive. American pilots learned they could tolerate the readout effect. Japanese pilots found that their aircraft handled poorly under negative glosses, discouraging pursuit through inverted maneuvers. By early 1944, the tactical balance in the Pacific had shifted dramatically. P-38 squadrons using vertical fighting tactics achieved kill ratios that reversed the earlier Japanese advantage. The 475th Fighter Group, which fully adopted the inverted dive technique by December 1943, recorded a kill ratio of 5-to-1 in their favor over the first quarter of 1944. Other squadrons reported similar improvements. The 5th Air Force in the Southwest Pacific began incorporating vertical maneuvers into official tactical guidance in March 1944. Nearly a year after pilots had started using them in combat, the delay reflected institutional caution about endorsing techniques that contradicted established doctrine and medical advice, but combat results made the case undeniable. Training materials began including sections on negative G flight, though the language remained cautious. Pilots were instructed that inverted maneuvers should be used only when facing imminent threat with no other escape option. The guidance emphasized brief duration, proper technique, and awareness of physical effects. It was permission without encouragement. Use this if you must, but were not recommending it. Pilots interpreted the guidance differently. If the tactic worked and command wouldn't prohibit it, that was authorization enough. By mid-1944, every P-38 pilot in the Pacific knew how to execute an inverted dive. Many practiced the maneuver during training flights despite official discouragement because they understood that the first time executing it shouldn't be with a zero on their tail. The physiological research continued. Flight surgeons documented that pilots could build tolerance to negative G-forces through repeated exposure. Similar to positive G-tolerance training, the body adapted, blood vessel walls strengthened, visual recovery time shortened with experience. Pilots who had executed 20 or more inverted dives reported less severe symptoms than those performing it for the first or second time. This created an experience advantage. Veteran pilots handled the maneuver more effectively than new arrivals. It became another skill that separated effective fighter pilots from those who didn't survive long enough to gain experience. Squadrons began informal mentoring where experienced pilots would take new arrivals up and demonstrate the technique in controlled conditions before they needed it in combat. The inverted dive wasn't just a maneuver. It became part of P-38 fighting culture in the Pacific. A shared experience that connected pilots across squadrons. When pilots from different units met, they'd compare notes about their worst readout, their fastest dive speed, or the time the tactic saved their life. It created a esprit de corps built around tactical competence and shared suffering. Japanese pilots adapted eventually. By late 1944, experienced Zero pilots learned not to follow P-38's through vertical maneuvers. They would break off pursuit when American fighters rolled inverted, knowing that attempting to follow was futile and potentially dangerous. This adaptation meant the tactic remained effective even after opponents understood it because it still achieved its primary purpose, breaking contact and preventing the Zero from establishing a kill position. The evolution continued through the war's end. Pilots experimented with variations. Some used a half roll before pulling through, which reduced negative G exposure, but required more altitude. Others combined the inverted dive with a barrel roll during the pull-out, creating an unpredictable flight path. The basic technique spawned dozens of tactical refinements as pilots adapted it to different situations. By war's end, the inverted dive and related vertical maneuvers had become fundamental to American fighter tactics. In the Pacific, the technique's legacy extended beyond World War II. During the Korean War from 1950 to 1953, American jet pilots rediscovered the principles their predecessors had developed over the Pacific. F-86 Sabre pilots facing Soviet-built MiG-15s found themselves in a situation similar to what P-38 pilots had experienced against Zeros. The MiG-15 could outturn the F-86 at most altitudes. Soviet and Chinese pilots exploited this advantage effectively. Captain Joseph McConnell, who became the top American ace of the Korean War with 16 confirmed kills, explicitly credited vertical fighting tactics learned from World War II veterans. In his debriefings, McConnell described using negative G dives to escape MiG attacks when caught in disadvantageous positions. The physics hadn't changed. The MiG pilot expected horizontal maneuvering, rolling inverted and diving, created separation and confusion. The jet era brought new complications. Jet engines of the 1950s sometimes experienced flameout during negative G flight as fuel delivery systems struggled with inverted operation. F-86 pilots learned to keep their maneuvers brief, not just for physiological reasons, but for engine reliability. 3 to 5 second inverted dive worked. Longer duration risked engine failure. Modern aviation medicine has extensively studied negative G-forces since those early World War II observations. Research conducted by the United States Air Force School of Aerospace Medicine beginning in the 1960s confirmed what Richard Bong and his contemporaries discovered through necessity. Humans can tolerate brief negative G exposure of -2 to -3 Gs with minimal long-term effects. The visual phenomenon pilots called readout occurs because blood pressure in the cranial blood vessels increases dramatically under negative G loads. The small blood vessels in the eyes engorge, creating the characteristic red visual field. Recovery is rapid once positive G flight resumes. Modern understanding shows that permanent damage requires either very high negative G forces above -5 Gs or sustained exposure lasting more than 15 seconds. Combat maneuvers rarely approached those extremes. Fighter aircraft design evolved to accommodate negative G capabilities. The F-16 Fighting Falcon, introduced in the mid-1970s, incorporated fuel systems specifically designed to operate under negative G conditions. The aircraft's fly-by-wire flight control system allowed sustained inverted flight without the engine problems that plagued earlier jets. Negative G maneuvers became an expected part of the F-16's performance envelope rather than an emergency technique. At the Navy Fighter Weapon School, commonly known as Top Gun, instructors teach negative G tactical maneuvers as standard curriculum. The program established in 1969 partly because American pilots in Vietnam struggled against more maneuverable MiG fighters incorporates lessons learned across 5 decades of air combat. One of those lessons traces directions directly back to Richard Bong over the Solomon Islands in 1943. When your opponent has a turning advantage, use the vertical dimension. Modern fighter pilots train with specialized equipment that helps them understand their physiological responses to negative G flight. Centrage training exposes pilots to sustain negative G forces in controlled conditions, allowing them to recognize the symptoms and learn their personal tolerance limits. The visual effects, discomfort, and recovery times are documented and explained as normal responses rather than indications of system failure. The F-22 Raptor and F-35 Lightning II, America's most advanced fighters, both incorporate thrust vectoring and advanced flight control systems that allow sustained high negative G maneuvers. These aircraft can maintain -3 to -4 gs for extended periods without engine problems or control complications. What Richard Bong achieved through desperate improvisation is now a program capability in 5th-generation fighters. The basic human factors haven't changed. Pilots still experience redoubt. Blood still rushes to the head. The discomfort remains. But modern pilots understand the phenomenon, train for it, and know it doesn't indicate danger. That's psychological shift from viewing negative G flight as potentially fatal to seeing it as merely uncomfortable represents a fundamental change in fighter tactics. The spread of this tactical knowledge illustrates how combat innovation occurs. Official doctrine and engineering typically lag behind what pilots discovered through necessity. Richard Bong didn't consult medical literature or engineering specifications. He rolled inverted because dying seemed worse than temporary blindness. That calculation, repeated by thousands of pilots over decades, gradually changed fighter tactics worldwide. The inverted dive and related negative G maneuvers remain relevant in modern air combat despite technological advances. Contemporary air-to-air missiles have excellent tracking capabilities, but they still require positioning and timing. A fighter executing a sudden negative G maneuver creates tracking problems for both missile guidance systems and pursuing aircraft. The unexpected vector change forces the enemy to recalculate intercept solutions, buying valuable seconds. During Operation Desert Storm in 1991, coalition pilots reported using negative G brakes to evade Iraqi surface-to-air missiles and air-to-air threats. The tactics' effectiveness persisted even against more advanced weapon systems. Physics and human reaction time don't change with technology. An opponent expects certain maneuvers based on common tactical doctrine. When a pilot does something outside that expectation, it creates decision paralysis, even if only for a few seconds. Those seconds matter. In air combat, a two-cond advantage in positioning can determine survival. Richard Bong understood that in 1943. Modern pilots with heads-up displays, helmet-mounted sights, and beyond visual range missiles face the same fundamental equation: survive the next few seconds, then use that survival to reverse the situation. The medical research continues. Studies conducted through the 2010s examined how modern GITs and flight equipment affect negative G tolerance. Standard GITs designed to prevent blood from pooling in the legs during positive G maneuvers don't help much during negative G flight. Some experimental systems attempted to restrict blood flow to the head during inverted flight, but pilot acceptance was poor. The equipment added complexity without providing benefits proportional to the additional weight and discomfort. Modern pilot training emphasizes that negative G maneuvers are Tools in the tactical toolkit, not emergency-only techniques. New fighter. Pilots learn inverted flight during basic flight training long before they encounter combat situations. This represents a complete reversal from the World War II era when pilots discovered the technique independently in training. Materials discouraged it. The shift reflects broader changes in how military aviation approaches innovation. The modern process includes structured testing, medical research, and official incorporation of new tactics into training programs, but combat still produces innovations faster than institutional processes can validate them. Iraq and Afghanistan saw pilots develop new tactics for close air support in urban combat that weren't in any manual but proved effective in actual operations. The pattern repeats. Pilots facing life or death situations innovate. Survivors share what worked. Eventually, the innovation becomes doctrine. This cycle, from desperate improvisation to standard procedure, characterized how the inverted dive evolved from Richard Bong's split-second decision over the Solomon Islands to a fundamental element of modern fighter tactics. Richard Bong finished the war as America's top-scoring ace with 40 confirmed victories. He survived the Pacific Air War and returned to the United States in 1945. On August 6, 1945, the same day the atomic bomb fell on Hiroshima, Bong was killed test flying a P-80 Shooting Star jet fighter engine failure during takeoff. He was 24 years old. The irony wasn't lost on those who knew him. Bong had survived hundreds of combat missions, pioneered tactics that saved countless pilots, and faced Japanese fighters across 2 years of intense combat. He died testing a new aircraft in relatively safe conditions. Combat veterans understood flying was inherently dangerous whether facing enemy fire or not. The risks never truly disappeared. Major Thomas Lynch, who documented and systematized the inverted dive technique, didn't survive the war either. He was shot down over Taji New Guinea on March 8, 1944, becoming one of over 33,000 American aircrew killed in the Pacific theater. His tactical innovations outlived him by decades, incorporated into training programs and fighter doctrine without most students knowing his name. The pilots who developed these techniques rarely received credit in official histories. No medals were awarded for inventing new maneuvers. The Medal of Honor went to pilots who shot down multiple enemies in single engagements, not to those who figured out better ways to escape when outnumbered. But among pilots themselves, the tactical innovators held special status. They were the ones who found solutions that kept people alive. Flight surgeon James Moorhead continued his medical research after the war, eventually becoming one of the leading experts in aviation medicine. His classified wartime reports on negative guysiology provided the foundation for decades of subsequent research. When the Air Force established formal aerospace medicine programs in the 1950s, Moorhead's data informed the training protocols and safety standards. The broader tactical lesson from negative G maneuvers extended beyond specific aircraft or historical periods. Combat forks innovation in ways that PCM training cannot replicate. The pressure of actual life or death decisions compresses learning timelines. What might take years to develop through systematic research and testing can emerge in weeks when pilots face it operationally. Military institutions struggle with this dynamic. Official doctrine requires validation through testing, safety analysis, and institutional approval. This process exists for good reasons. Untested tactics can get people killed as easily as effective tactics save them. But combat doesn't wait for official approval. Pilots improvise, and effective improvisations spread through informal networks faster than formal institutions can evaluate them. The inverted dive illustrated this tension perfectly. By all official measures in 1942 and early 1943, the maneuver should have been prohibited. Medical guidance suggested it was dangerous. No training program taught it. Engineering specifications for most aircraft didn't validate it. Yet, pilots used it anyway, because the alternative was worse. This created a command dilemma. Squadron leaders and higher headquarters knew pilots were using the technique. They saw the survival rates improve, but officially endorsing something that contradicted established safety guidance created liability issues. The compromise was tactical ambiguity. Don't prohibit it, don't endorse it. Document the results and let the medical and engineering staffs catch up with operational reality. By 1944, enough Data existed to change official positions. The medical research showed the technique was survivable. Engineering tests confirmed that properly maintained aircraft could handle the stresses. Training programs began incorporating it, though cautiously. The institutional processes eventually validated what pilots had proven in combat a year earlier. Modern military organizations try to shorten that validation cycle. After-action reporting systems, rapid assessment protocols, and flexible training programs attempt to capture and disseminate tactical innovations faster. But the fundamental tension remains. Combat generates innovation faster than institutions can officially incorporate it. The inverted dive also demonstrated how tactical knowledge transfers across generations of pilots. The technique developed in World War II against Zeros influenced Korean War pilots facing MiGs, which informed Vietnam War tactics, which shaped training for Gulf War operations, which affected how contemporary pilots think about air combat maneuvering. Each generation refined the technique, adapted it to new aircraft and situations, and passed it forward. This continuity exists despite massive changes in technology. World War II pilots flew propeller-driven aircraft with mechanical controls. Modern pilots fly jets with computer-managed flight systems. But the underlying principles of energy management, opponent psychology, and physiological tolerance remain constant. A pilot from 1943 transported to 2024 would need extensive training on the equipment, but the tactical concepts would be immediately recognizable. Institutional memory preserves this knowledge. Fighter squadrons maintain traditions and unofficial histories that capture lessons beyond what appears in official documentation. When a new pilot joins a squadron, experienced pilots share stories about tactics that worked. Pilots who innovated effectively in situations where unconventional thinking saved lives. The inverted dive features in those stories directly or indirectly as an example of effective tactical innovation. The technique also illustrates human adaptability under stress. The physical effects of negative G-flight are intensely uncomfortable. Headaches, visual distortion, nausea, disorientation. Every physiological signal tells the pilot this is wrong, dangerous, to be avoided. Yet thousands of pilots learned to ignore those signals because they understood the larger context. Temporary discomfort beats permanent death. That calculus requires a specific mental framework. It's not courage in the traditional sense. It's more analytical assessment of relative risks. Understanding that the body's warning systems evolved for different threats than high-speed aerial combat. Recognition that survival sometimes requires accepting short-term suffering to avoid long-term consequences. Modern fighter pilot training explicitly develops this mindset. Pilots learn that their instincts will sometimes be wrong. In aerial combat, the natural response to seeing the ground rushing up is to pull back, climb away. But in certain situations, diving toward the ground creates escape opportunities. Training builds cognitive frameworks that allow pilots to override instinct when tactical analysis indicates a different action. This represents sophisticated decision-making under extreme stress. In the seconds available during air combat, pilots must assess the tactical situation, evaluate options, predict opponent responses, calculate relative risks, and execute maneuvers that may contradict instinct. The pilots who survive develop this capability. Those who don't rarely get a second chance to learn. The inverted dive became one element in a larger tactical repertoire. Effective fighter pilots mastered dozens of maneuvers, each applicable in specific circumstances. They learned to recognize which situation called for which response, often at speeds where conscious deliberation wasn't possible. The knowledge had to become almost automatic. See this threat pattern, execute that maneuver sequence, adjust based on result. Building that automatic response requires extensive training and experience. Pilots in World War II typically needed 15 to 20 combat missions before their tactical decision-making became reliable. Modern pilots spend hundreds of hours in simulators and training aircraft before their first combat deployment, attempting to compress that learning curve. But combat still teaches lessons that simulation cannot fully replicate. The emotional stakes drive different learning. In training, mistakes mean embarrassment, negative evaluations, or at worst, minor injuries. In combat, mistakes mean death. That reality focuses attention powerfully. Pilots, remember combat lessons with a clarity that training lessons rarely achieve. The memory of executing an inverted dive. With a 0 on the tail, feeling the readout effects, seeing the maneuver work, reinforces the technique far more effectively than any classroom instruction. Post-traumatic learning is real and remarkably powerful. Aviators who survived by employing the inverted dive didn't require refresher drills on the maneuver. The combination of fear, bodily sensations, and successful execution formed permanent neural pathways. They could perform the maneuver years later with the same precision demonstrated during that initial desperate combat encounter. This insight has implications for the evolution of fighter tactics. The most effective techniques frequently arise from extreme stress situations where pilots had no opportunity for detailed analysis. They relied on instinct, training, and immediate tactical judgment. When those actions succeeded, the success reinforced the behavioral pattern. Other pilots observed or heard about it, tried it themselves, and either confirmed it was effective or discovered its limits. The decentralized development of tactics through this process fosters resilience. No single theorist or test pilot declared inverted dives effective against zeros. Numerous pilots independently realized it worked. The maneuver survived and spread because it proved effective across diverse conditions and scenarios, natural selection in its most literal sense. Tactics that worked proliferated. Tactics that failed cost pilots their lives and vanished from practice. Modern military organizations attempt to formalize this evolutionary process through structured experimentation and operational testing. Red flag exercises, training centers simulating combat conditions, and after-action review systems all aim to create environments where tactical innovation can emerge and be assessed without actual conflict. These mechanisms function reasonably well. They have accelerated the development cycle for new tactics compared to historical patterns. But combat continues to produce unexpected challenges. Operations in Iraq and Afghanistan generated tactical adaptations unforeseen by training or doctrine. Close air support in urban terrain, counter-IED missions, and integration of unmanned systems all demanded innovations born from operational necessity. The pattern persists. Combat creates problems, operators improvise, effective improvisations spread, and eventually institutions codify them into doctrine. The inverted dive holds a unique place in this history because it represents one of the earliest systematically documented examples of combat-driven tactical innovation. During World War II, particularly in the Army Air Forces, relatively sophisticated systems existed for capturing and sharing tactical lessons. After-action reports, technical bulletins, and training updates disseminated knowledge across theaters faster than in previous wars. This allowed the inverted dive maneuver to spread among Pacific P-38 squadrons within months of its initial application. Pilots in the European theater facing different aircraft and adversaries did not adopt it as widely because tactical situations differed. Yet the principle of vertical maneuvering to exploit aircraft performance advantages transferred. Pilots confronting FW-190s or Mi-109s developed their own techniques to use dive performance to escape disadvantageous engagements. The technological continuity across fighter generations illustrates how fundamental principles endure despite dramatic equipment changes. A P-38 pilot from 1943 and an F-35 pilot from 2024 operate aircraft separated by 8 decades of technological progress, yet both comprehend that when confronting opponents with superior turning capabilities, vertical maneuvers provide escape options that horizontal tactics cannot. Knowledge transfer occurs through multiple channels. Formal training programs teach these maneuvers explicitly. Informal mentorship passes tactical wisdom from seasoned pilots to newcomers. Historical study provides context for how techniques developed and evolved. Together, these methods create institutional knowledge resilient to personnel turnover and technological transitions. The Vietnam War provided another crucible for negative G tactics. American F-4 Phantom pilots confronted North Vietnamese MiG-17s and MiG-21s capable of outturning them in specific flight regimes. The F-4, optimized as a missile platform for beyond visual range engagements, was disadvantaged in close-range dogfights against smaller, more maneuverable fighters. Navy Lieutenant Randy Cunningham, the first American ace of the Vietnam War with 5 confirmed kills, deliberately employed vertical maneuvers, including negative G dives, to escape disadvantageous engagements with MiGs. On May 10, 1972, when he shot down 3 MiG-17s in a single sortie, Cunningham executed an inverted dive to disengage from a MiG that had briefly achieved a tail position. The tactic succeeded for the same reasons it had against Zeros 3 decades earlier. The enemy anticipated horizontal maneuvers, and sudden vertical displacement caused separation and confusion. Cunningham used that separation to regain the advantage and re-engage. The physics had not changed, nor had the opponent's psychology. Its effectiveness persisted. Vietnam also demonstrated how institutional knowledge can be lost and later rediscovered. By the mid-1960s, many World War II and Korean War veterans with expertise in close-range aerial combat had retired. Younger pilots trained in a missile-focused era lacked the tactical repertoire of their predecessors. This recognition directly led to the establishment of Top Gun and similar programs. The Navy Fighter Weapons School opened in 1969 to address deficiencies in air combat maneuvering skills. Instructors, many Vietnam veterans like Cunningham, taught techniques tracing their lineage from Korea and World War II. Inverted dives and negative G maneuvers became part of the curriculum. Modern Top Gun instruction includes modules on negative G applications, covering physiological effects, proper execution, and scenarios where the maneuver offers advantage. Students practice repeatedly in training aircraft to build muscle memory and physiological tolerance, ensuring the technique is available under combat stress. Training also emphasizes understanding why the tactic works. Modern fighter pilots must comprehend enemy decision-making, missile dynamics, and radar limitations. Negative G maneuvers serve multiple tactical purposes beyond evading aircraft, including breaking radar locks, complicating missile tracking, and creating counterattack opportunities. The same physical movement provides diverse advantages depending on the threat. Contemporary aerial combat adds complexity unimaginable to World War II pilots. Modern fighters carry missiles with sophisticated guidance capable of tracking targets through maneuvers that would have been impossible for gun-only aircraft. Helmet-mounted sights allow weapons targeting without moving the aircraft. Sensor fusion delivers 360 degrees awareness, eliminating historical blind spots. Yet the advantage of unexpected maneuvers endures. Missile seekers still require processing time for sudden flight path changes. A brief negative G dive creates seconds of confusion sufficient to break the kill chain. The F-35 Lightning II incorporates design features facilitating negative G maneuvers as an intended capability rather than emergency options. Fly-by-wire systems maintain stability in maneuvers previously uncontrollable in mechanical aircraft. Fuel systems ensure engine operation regardless of orientation. Ejection seats function safely during inverted flight. These engineering improvements reflect the influence of tactical requirements on aircraft design. Unlike the P-38, the F-35 was purpose-built to support these maneuvers. Physiological challenges remain. Pilots still experience red-out, vision distortion, and blood rush to the head. Modern suits and life support systems manage these effects rather than prevent them. Pilots train to operate under such conditions, accepting temporary discomfort in exchange for tactical advantage. This represents the culmination of 8 decades of accumulated knowledge. World War II pilots learned negative G flight was survivable. Korean War aviators confirmed it under different circumstances. Vietnam pilots relearned it following institutional forgetting. Modern pilots integrate it as standard procedure. The technique evolved from improvisation to validated capability. The broader lesson applies beyond negative G maneuvers. Combat generates constant tactical innovation. Effective militaries capture, validate, and transmit these insights across generations. Institutional resistance and forgetting impede progress, but effective techniques survive. Richard Bong's split-second decision over the Solomon Islands in 1943 began a chain of tactical evolution continuing to this day. He could not have foreseen that a maneuver executed to save his life would influence fifth-generation stealth fighter engagements 8 decades later. Yet the connection exists, documented through continuity in pilot culture and institutional memory. Military historians often focus on equipment, strategy, and high-level decisions, which matter greatly. Yet operational-level innovation by individuals confronting immediate life or death decisions shapes wars as profoundly as overarching strategy. Pilots who discover what works in combat and survive to share their experience generate effects that ripple across generations. The inverted dive exemplifies this. No admiral or general mandated its development. No engineering team initially designed aircraft for it. It emerged from necessity, proved effective in repeated use, spread through informal networks, gained recognition, and became foundational to modern tactics. Battlefield improvisation evolved into doctrinal standard, illustrating how militaries learn and adapt. Official procedures matter, but combat realities drive evolution. Pilots facing Zeros in 1943 and modern threats today encounter the same core challenges: physical limitations, enemy capabilities, and the imperative to survive while completing the mission. Solutions reflect these constraints more than technology or doctrine. Human decision-making remains central. Fighter combat is decided by split-second judgments under extreme stress. Technology enables, training builds skill, tactics guide, but ultimately, the pilot must assess, decide, and execute. This human element connects Richard Bong and contemporary F-35 pilots. The specific maneuver may eventually become obsolete with future aircraft or autonomous systems, but the principle endures. Shift to a dimension of advantage, act unexpectedly, and accept temporary discomfort for tactical gain. These principles applied in 1943, in Korea, Vietnam, the Gulf Wars, and will continue to apply. If this story resonated with you, we would be honored if you liked this video. Tell us where you are watching from, your country and city. Did someone in your family serve in the Pacific, Korea, or Vietnam? A father, grandfather, or uncle who flew fighters? Share your memories below. These stories connect generations. Pilots who pioneered these tactics could not have imagined that 80 years later, we would still discuss their innovations. Their courage, ingenuity, and willingness to exceed limitations created knowledge that saves lives today. Thank you for watching. Thank you for remembering. These stories must not be forgotten.